Okay, let's start. Assalamualaikum and good day. My name is Ahmad Imran and I am from Group LO3 of Data Structure and Algorithm subject. And me and my group members, Muhammad Mirza, Muhammad Zaim and Fawaz Kawim would like to present about our project assignment for this subject, which is data structures of Google Chrome. So on to the next slide.
Okay, for the next slide, for the application title, we choose is the implementation of stack and queue in Google Chrome. For description, Google Chrome browser is an open source program for accessing the World Wide Web and running web-based application. Next, Google Chrome was first released in to 2008 and available for Windows, Mac OS, Linux, Android, and iOS operating system. Chrome also was the first major web browser to combine the search box and with the address bar, a feature that has recently been adopted by most competitors. For this project, we are using the stack and queue for the Google Chrome. Next.
Okay, I will explain about our applications operation. So first of all is back button and forward button. It is used, stack and queue is used as we move from one page to other page and place in stack. URLs website store stack. Current pages store on top of stack. When press back button, the previous web page will reverse in order. Search bar array is used as search engine. Use it to store web page found on behalf of the search performed by the user. History. Link list is used as when URLs added to the history. It will be at the end of the linked list when other URL added. When the last URLs is being used again, it will be on the first of the linked list.
Okay, moving to the next question, which is the demonstration of the data structure we've chosen, which is stack and queue that is applied in Google Chrome. So firstly, Google Chrome, as we just said, features a back and forward button to navigate through web pages back and forth. This feature specifically uses the stack and queue data structure elements. Here, we will demonstrate how stack and queue works when the back and forward buttons are clicked in Google Chrome. So the illustration here shows that every page that will be visited will be stacked in respective order. So for example, in this illustration, the first page is 11, as we can see in the bottom of the stack. Then the next page is 23, and the next page is -8, and the process goes on as long as there are new web pages visited. The newest page will always be on top of the stack. Next slide. So here we will explain a bit further regarding the how the stack works. So in this example, we created two stacks, which are forward stack and backward stack. These stacks are made to store the data for the current page we are visiting, which is the page displayed. In this coding, the page displayed is named current_state_URL. And when the back button and forward button are clicked, this means that when we are visiting a page, the stack will be the data will be stored in these specific stacks. Okay, next. In stack and queue, the push and pop operations are used, where push adds an element into the stack and pop removes an element. And when the forward button is clicked, the web pages from the bottom of the stack will move to the top of the stack in respective order. For example, the current page will be pushed into the backward stack to be ready if back button is clicked and new page will be displayed. This means that if the current page will be added into the backward stack, so if we click the back button, the previous page will be displayed. Then the new page is set to the top of the forward stack, as it is the latest page to be visited using forward button. And lastly, the forward stack is popped as there are no more pages after the current page. This means that if you are in the latest page, you cannot use the forward button again. Okay, next slide. And when the back button is clicked, it will be going from the top of the stack to the bottom of the stack. This means that it navigates from the latest web page to the earliest web page that have been visited. The current page will be pushed into the forward stack to be ready if the forward button is clicked and the new page will be displayed. Then the new page will be set to the top of the bottom stack as it is the latest page to be visited using the back button. And lastly, the backward stack is popped as there are no more pages before the current page. So in regards of the forward button, the backward button just works vice versa to the forward button. So next. Oh, okay.
Okay, for the 3I, which is this the coding of text that we found in the internet. Okay, next. So this is the running time for algorithm that we found in coding. So the first one, can you go to the back slide? Okay. First, I choose for running time. I choose the line 22 until 26. So next slide, please. So the first I for the line 22, I got 5n. My 5n. 5n minus 0 plus 1 equal by 5n plus 1. So the second is 5n minus 0 times 1 equal by 5n. So the total is the total n is 10n plus 1. So next we have to remove the constant variable which is 10 and 1. So only left the n. So the final answer is O of n. Okay, next slide.
Okay, conclude on the findings. All implemented interface element serializable. It is a marker interface that class must implement if they are to be serialized and deserialized. Clonable. This is an interface in Java which needs to be implemented by a class to allow its object to be cloned. Collection E. A collection represents a group of objects known as its element. The collection interface is used to pass around collection of objects where maximum generality is desired. List. The list interface provides a way to store the ordered collection. It is a child interface of collection. Stack data structure is the basic push and pop operation. The class provides three more functions of empty stack. and peak. This is the illustration how of the code, previous code is working. Okay, moving on.
Okay, for number 4, creation class and the interface use. So this is the coding that we found on the internet. For this coding, this is the example for backward. And next, so this is the example for coding forward. Next. So the conclusion and the summary. So what can we conclude is a stack linear data structure that only enable operation on one end, which means that all basic operations such as insertion may only be performed at the structure's end. The operation simply add data to the queue. The first will also analyze the queue before being added to it, while the second will delete the data from the queue. Running time for the algorithm is O n. So this is all from us. Thank you.